Up to this we covered collection and what are various methods are there, list and its specific methods. Now we have to talk about implementation classes, right? The first implementation class, ArrayList, linked list, vector, stack. These are things I have to explain. Now keep subheading ArrayList. The first implementation class of list is ArrayList, of course. Here the first one, observe ArrayList. ArrayList. Okay. So the first point, what is underlying data structure for ArrayList? Do you know? So every collection class is implemented based on some standard data structure. Based on which data structure ArrayList concept is implemented in Java is resizable array, or growable array. Resizable array or growable array. So underlying data structure for ArrayList is resizable array or growable array. Now the second point, can you tell duplicates are allowed or not allowed? Duplicates are allowed because ArrayList is under list. So duplicates are allowed. Duplicates are allowed. Third one, insertion order is preserved or not? Yes. So in which order we inserted? In the same order only the objects will be stored internally. That's why insertion order is preserved. Insertion order preserved. Next, is it possible to insert heterogeneous objects or not? I want to insert different type of objects. Possible or not? Yes. Heterogeneous objects. Heterogeneous means what? Different data type, different type of objects. Heterogeneous objects, happily we can insert, there is no problem at all. Heterogeneous objects are allowed. Okay, this is. So here one very important conclusion you should aware. In total collection framework, everywhere heterogeneous objects are allowed except two places. One is tree set, the other one is tree map. Because in tree set and tree map, the objects are going to be stored in some sorting order. Tree set means sorted set, some sorting order. Here also some sorting order. To arrange elements in some sorting order, compulsory we require to compare objects. To compare objects, whether this object has to come before this or after this, to identify this location, assume x and y. I have to place this x after y or before y. Compulsory comparison is required. If a comparison is required, compulsory these objects should be homogeneous, right? That's why make sure except tree set and tree map, everywhere heterogeneous objects are allowed. Okay, this is, that's why. So except tree set and tree map, everywhere heterogeneous objects are allowed. Okay, this is, I will give the notes anywhere, right? Next, null. Is it possible to insert null or not? Okay, null insertion is possible. Null insertion is possible. Are you getting? So some important points related to ArrayList. These are, what is underlying data structure? Duplicates are allowed. Insertion order preserved. Heterogeneous objects are allowed. Null insertion is possible. Okay, this, take all these. That's all. Are you getting right? So basic idea, the general conclusions about ArrayList is nothing but like, okay, this is. Now I will explain what are various constructors are there in the ArrayList, and I will go for a small demo program for ArrayList. Keep subheading constructors. 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 Constructors, right? Okay, first constructor, listen. array list L is equal to new array list. Don't write legend array list L is equal to new array list. Do you know we are creating an empty array list object. Are you getting? I am creating an empty array list object, but make sure what is the default initial capacity. Okay, what is the default initial capacity of this array list is 10. 10 is the default initial capacity. So we are creating an empty array list object with the default initial capacity 10. Then immediately here some clarity must be required. I added first object, second object, third object, like 10th object also. Now 11th object I am trying to insert. If I am trying to insert 11th object, internally what will happen is, so once array list reaches its max capacity, a bigger array list object is going to be created. Are you getting? A bigger array list object is going to be created. Copy all these things, x1, x2, x3 and so on, x10, and then x11 by default is going to be placed, and reassign this reference variable to the new object. Old object by default eligible for garbage collection. We know I explained this concept somewhere in the last classes, right? But now my doubt is, what is the new capacity of this array list? Already default initial capacity 10, but what is the capacity of, what is the new capacity, or what is the capacity of this newly created array list? Now the capacity is equal to, new capacity is equal to current capacity into 3 by 2 plus 1. Current capacity into 3 by 2 plus 1. This is the formula followed by some people, right? Is it clear for all of you? Once a array list reaches its max capacity, a new array list object will be created with the new capacity is equal to current capacity into 3 by 2 plus 1. Now observe this one, 10. 10 is the current capacity. 10 into 3 by 2, what about its value? 15 plus 1. So this 10 will become 16. Suppose 16 also completed. 17th element we are trying to insert. If 17th element we are trying to insert, 16 into 3 by 2 plus 1. What about its value? 16 into 3 by 2. 24 plus 1 is nothing but 25, like a dot. Are you getting? So this is the first constructor what we have, okay, at this point. So this is the first constructor what we have, okay. This is, now let me go for second constructor, right? Here like that, array list is equal to new array list. We are creating an empty array list with the default initial capacity 10. But now there is a problem. Suppose I want to insert 1000 objects. First create 10 capacity, and then create 16, copy all these 10, and then create 25, copy all these 16. Performance of the system is going to be down. Are you getting? That's why don't you create a big array list object with the required capacity at the beginning only? If you want, then we should go for second constructor, right? Array list L is equal to new array list of int initial capacity. Now how much capacity you want? With that capacity directly we can able to create array list object, so that performance of the system by default is going to be improved if I can use this based on our requirement. So I want to, I'm sure 1000 objects I'm going to add, then better to go for this constructor, right? This is the second constructor. Now the third one, this constructor is a bit important. I have one linked list is there. I want to create an equivalent array list, or I have tree set is there. I want to create an equivalent array list. So then which constructor? Array list L is equal to new array list. Array list L is equal to new array list of collection C. Collection C is for any collection object. It may be linked list, it may be vector, or it may be stack. For any collection object, if you want to create an equivalent array list object, then we should go for this constructor. But make sure this type of constructor meant for inter-conversion between collection objects. Linked list to array list, or vector to array list, or tree set to array list. For any collection object, if you want to create an equivalent array list object, then we should go for this constructor. Are you getting right? Okay, this. So total how many constructors are there in the array list? 3 important constructors, right? Okay, this. That's all. Now I will explain a simple example how to create array list object, how you can perform insert, like a simple demo program. Let me explain. Okay, here just observe. Here I am taking import java.util.star. Can you tell why I am taking java.util.star? Because array list class present where? In the util package, java.util.arraylist. Class ArrayList demo, public static void main, ArrayList L is equal to new ArrayList. I am creating one ArrayList object, right? Okay, this here. Now L dot add of A 10 A null. So how many elements we inserted? 4 elements. SOP of L is nothing but just observe the terminology, right? Just see this one. So ArrayList L is equal to new ArrayList. L dot add of A 10 A null SOP of L. If you consider here, what is the output by default we are going to get? Okay, make sure. Can you tell what is this L? L is ArrayList object. I am trying to print ArrayList reference. Internally, here I have observed square bracket. What is the first element we inserted? A. Second element we inserted 10. Third element we inserted A. Fourth element null. This is the output we are going to get. But now make sure, very important point. Why we are getting square bracket notation for this array list? Simple. Whenever we are trying to print any object reference, internally which method will be called? ToString method. SOP of L dot ToString method will be called. L dot ToString method will be called. In every collection, how the ToString method is implemented? Open square bracket, first element, second element, third element, fourth element, like our collection element will be placed inside square bracket. That's why this output by default we are going to get. That's why, so in any collection, square bracket the elements, right? So for the first SOP, what is the output we are going to get? It's a very clear A 10 here. So if you consider A, okay, this is A 10, next and after that A comma null we are going to get. But here if you observe, duplicates are allowed or not? Allowed, because how many times A we are taking? 2 times. Heterogeneous objects are allowed or not? Yes, because one is the string object, the other one is the integer object we are. Null insertion possible or not? Yes. Next, in which order we added? In the same order only internally stored. That's why the output we are going to get A10 A null. Next, L dot remove of 2. Anna, can you please remove second element? Remove the element locating at second index. I want to remove. If you want to remove the second element, which one is A? 0, 1, 2 is nothing but A will be removed. After removing second element, SOP of L. Have you observed? What is the answer by default we are going to get? Yes, second element by default got removed. What is the remaining part? A. Next and after that 10. Next and after that null is nothing but like we have null. Okay, like. Next, L dot add of 2 comma m. Can you please add m at second index place? If you want to add m at second index place, now here m will come. M will come after 10 second index place. And then L dot add of n. Now, can you please, n will be added where? At last, because normal add method is always going to add at last, null comma n like. So, if you are trying to print SOP of L, what is the output by default we are going to get is, can I spell out what the answer? A, comma, 10, comma, have you observed this m added at second place? That's why m, comma, already existing element, null, comma, last element is nothing but n. This is the output by default we are going to get. I hope is clear, right? Okay. Let me compile and run this program. ArrayList demo is nothing but like, now Java C ArrayList demo, ArrayList demo.java. Happily the code is going to compile, no problem at all, because these are just warnings, because generic syntax came in the 1.5 version. I'm not using generic syntax, that's why. Anyway, once we started using generics, these warnings also will be gone. Java ArrayList demo, now observe the output. First time A10 null, second time A10 null, but third time is nothing but A10 m null n. I hope you people are able to understand clearly. Okay, this is a simple program, simplest, how to create ArrayList object, how you can perform some common operations, some general operations on the ArrayList object. This program is going to demonstrate, right? Okay, this is, take this program. Okay, so up to this we covered what is ArrayList, how to create ArrayList, and how we can add some elements to the ArrayList, some common methods, whatever we discussed up to this. Now there are some common points about ArrayList. There are some more important conclusions are there, which may related to ArrayList or may related to all collections also. Okay, now mostly for which purpose we can use collections? Collection, the equivalent term in the C++ is container. Have you remembered? Container. Mostly for which purpose we can use collections or containers? To hold data and to transfer. Correct, right? What is the need of containers? To transfer our goods from one place to another place. Correct. Container is our collection. To hold data, to hold our objects and to transfer across network. For that purpose we can use container or collection, right? In the C++ we can use container, but in Java we can use what? Collection, right? So for which purpose we can use collection? To hold and transfer objects from one place to another place. For that purpose we can use collection, right? But to transfer objects from one place to another place across the network, compulsory the object should be serializable object. Correct or not? Okay, this. If you want to transfer object from one place to another place, compulsory the object should be serializable object. To provide support for this requirement, every collection class, maybe ArrayList or linked list, vector, stack or tree set, like every collection class already implements serializable interface. Are you getting ready? Every collection class. So ArrayList is a serializable or not? Yes. So linked list serializable or not? Yes. Tree set already serializable, right? So to implement, to provide support for this type of requirement, every collection class by default implement serializable interface. Any collection class by default implement serializable, right? First conclusion, right? Next, second one, suppose I have one ArrayList object is there. Here there are several student objects are there. I want to send this object across a network. across the network I want to send. So this object already serializable. Yes, happily this object can able to travel across network. Okay, this. Next, after reaching, now the receiver got my ArrayList object. Yes, receiver got ArrayList object. But most of the times, receiver won't perform any operation directly on this object, because if something goes wrong, then we may not recover, right? That's why after reaching this object, immediately the receiver is going to create exactly duplicate object for this. So the process of creating exactly duplicate object is by default considered as cloning. Are you getting that? Okay, this. So cloning is the very common requirement for collections. That's why. So every collection class already implements clonable interface. Okay, this is any collection class, ArrayList class, linked list, like. So usually we can use collection to hold and transfer data across the network. To provide support for this requirement, every collection class already implements serializable, already implement clonable interface, and it is the common point for any collection object. So ArrayList, linked list, vector, stack, tree set, hash set, like every collection class already implement serializable and clonable interface. Is it clear for all of you? Okay, this. Take this point. So now can you tell ArrayList implements serializable or not? Linked list implements clonable or not? Yes. Any collection class already implements serializable and clonable interfaces, right? Okay, this. Next, there is another specific point, but this point is not a general point for all collections. It is the point related to only ArrayList and vector. Okay, this point is also very important conclusion, right? Now listen. So in ArrayList class and the vector classes, ArrayList and vector implement random access interface. ArrayList and vector implements what? Random access interface. So what is the advantage of implementing random access? So any random element we can access with the same speed. Are you getting right? Random access. Any random element we can access with the same speed. Best example, suppose in the ArrayList, I have a group of objects are there, like 1 crore objects are there. And what is the first element in ArrayList? Oh, first element is X. Like within 1 second I can able to tell. Assume, what is the 10th element? What is the 10th element? Within same 1 second only, yes, 10th element is the Z. Like I can able to tell. So what is 1 croreth element? Is nothing more. 1 croreth element is M. Within same 1 second only I can able to tell. Are you getting? So ArrayList and vector classes implement random access interface so that any random element we can access with the same speed. Are you getting right? Okay, this. So either first element or 1 lakh element or 1 crore element, within just 1 second only I can able to respond. This type of ability just because of implementing random access interface. Are you getting right? But this type of support is available only for ArrayList and vector classes, right? Are you getting? Only ArrayList and vector implement random access interface so that any random element we can able to access with the same speed. Is it clear for all of you? Right? So can you tell? So ArrayList implements random access or not? Ayo, ArrayList implements random access or not? Yes. Linked list implements random access? No. Because only ArrayList and vector implements random access. But what about serializable? Any collection class. What about clonable? Any collection class. But random access implemented by only ArrayList and vector. Are you getting? So if our frequent operation is retrieval operation, I want to retrieve the element, ArrayList is the best choice because any random element we can able to access with the same speed. Is it clear, right? Okay, this that's why any random. So if our frequent operation is retrieval operation, then highly recommended to go for ArrayList or vector concept, right? Okay, the terminology is very clear for all of you, right? Okay, this but there are few points. Random access, this one where it is available, java.util package. Random access present in java.util package. Random access interface contain how many methods? Ayo, it's an interface. Contain how many methods? No method. It is a marker interface. Very important for the entire room. Can you please talk about random access? Random access implemented by ArrayList and vector. Random access present in util package, and it doesn't contain any method. It is what? Marker interface, right? Okay, marker interface, right? Add up to this. Okay, now few points about random access. Keep subheading random access. Random access, single word, don't give the space in the middle. Random access. So implementing random access, how many classes implements random access? Only ArrayList and a vector, not the remaining things. Okay, this say. Now based on just this point, what is the possibility to ask the question for the interview room or for the exam? Just observe this one. Here have a look. Here just have a look about this point, right? ArrayList L1 is equal to new ArrayList. I am creating one ArrayList object. Linked list L2 is equal to new linked list. Okay, L1 instance of serializable. Can you tell L1 is what? L1 is what? ArrayList. ArrayList, is it serializable or not? Yes. That's why what is the answer by default we are going to get is true. True is the answer. Next, L2 instance of clonable or not? Yes. Every collection class already implement clonable interface. That's why. So what is the answer by default we are going to get is nothing but a true. Okay, like L1 instance of random access. Now ArrayList implements random access or not? Yes. That's why what answer by default we are going to get is the true. True is the answer, right? Okay, like next L2 instance of random access. Linked list doesn't implement random access. That's why what answer by default we are going to get is the false, right? I hope you people can able to understand. So this is the possibility to ask the question for the exam or for the interview room, right? So every collection class already implement random access, already implement serializable, clonable, but only ArrayList and vector classes implement random access, but not every collection. Okay, like take this part, take this example. Now observe where ArrayList is the best choice, where ArrayList is the worst choice. Are you getting that? There are some situation where we should go for ArrayList. There are some situation where we should not go for ArrayList. If our frequent operation is retrieval operation, sir, I want to retrieve. If our frequent operation is retrieval operation, then ArrayList is the best choice. What is the reason? Because ArrayList already implements what? Random access interface, right? That's why if our frequent operation is any random element, we can able to access with the same speed. That's why if our frequent operation is retrieval operation, then ArrayList is the best choice. Are you getting right? But where ArrayList is the worst choice? There are some situation where ArrayList is the worst choice. Just observe this. Suppose my ArrayList contain 1 crore elements are there. Just assume 1 crore elements are there, this ArrayList object. Okay. So here x, y, z dot 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 is nothing but there. Now my target is I want to add an element in one index place. Anna, can you please add one element m? This is my requirement. Add m in the one index place. But in the one index place already y is there. Are you getting right? Now I want to add m. Add, it is not replacement. That's why here to place this m here, compulsory this y should be shifted to this place. Are you getting? Next, but in this place already z is there. This z should be shifted here. Next, this element should be shifted here. This element should be shifted here. Just to insert m in the middle in the one index place, how many shift operations are required? 1 crore shift operations are required. Are you getting right? Just suppose today you are asking, sir, can you please add m in the one place? Maybe after 6 months or 1 year, it is going to tell successfully inserted, right? So if our frequent operation is insertion in the middle, then ArrayList is the worst choice. Are you getting? Because internally there are several shift operations are required. Okay, this same rule applicable even for delete also now. L dot remove of 1. L dot remove of 1. Can you please remove the element locating at first index place? Now first index is nothing but this. Yes, I remove. If I remove, vacant cell should not be there in the middle. This element should be shifted here. This element should be shifted here. This element should be shifted here. How many shift operations are required once again? 1 crore. That's why if our frequent operation is removal in the middle, then ArrayList is the worst choice. Are you getting right? So can you tell when ArrayList is the best choice? When ArrayList is the worst choice? If our frequent operation is retrieval operation, highly recommended to go for ArrayList. If our frequent operation is insertion in the middle or removal, ArrayList is the worst choice, right? Is it clear for all of you, right? Okay, at this point. That's all. Are you able to understand, right? So what is ArrayList? When ArrayList is the best choice, when ArrayList is the worst choice? Can you please explain about random access? Is nothing but like you people should have clarity, right? That's all. There ends what is ArrayList concept.